Welcome back, friends. Let's talk about the multiplication and division rules now. So if I have two numbers given to me, one is 6 times 5. I wanted to multiply these two numbers. My answer, plain and simple, is 30. Then if I put the negatives and positives into the numbers, then what's going to happen? Let's see. 6 times negative 5. What will be my result? My result will come out to be negative 30. And if I change the number to negative 6 times 5, my answer will come out to be 30, again negative. Then if I change the number negative 6 times negative 5, my answer will be positive 30. So let's analyze these four options and try to make some rules. So when a positive number is multiplied with a positive number, our answer will always be a positive. When you have a positive number and a negative number, a positive and multiplied with a negative number, your answer will always be negative. And then in the third scenario, a negative number multiplied by a positive number, still the answer will remain as negative. When you have two negative numbers, so when there is a negative number times a negative number, your answer will come out to be a positive. So remember these rules, keep them in your back pocket, so that when we will be applying them on algebra, we can use them. So again, if someone doesn't understand the concept of the like term, he can watch my previous video. I've already talked about the like term, so I'm gonna start by taking some like terms and dislike terms, unlike terms, shall I say. So if the x and x, are they the like terms? Yes, they are the like terms, because the base, the variable part, is the same, and then the exponent, if there's nothing, it means there's one, and the exponent of both them is same. So when I will multiply x times, I'm going to represent it with the dot. The dot means the timesing. So x times x is x square. So what I'm doing, when we multiply like terms, we add the exponents and the constants multiply like regular terms. So in this case, if I look into the details of this question which we've taken, so if there is nothing on top, it means always there is one on top. So when there are they the like terms? Yes, they are the like terms. So when we have like terms, we add the exponents. So the exponent is 1 and the exponent of this one is 1. So I added the exponent. I got the answer as 2. 1 plus 1 is 2. Now what is the second part of this? It says when we multiply the like terms, we add the exponents and the constants multiply like the regular terms. So what are the constants? So remember, if there is nothing, the term which is in front of the variable is called the constant, or the term in front of the base also. This is called base or variable. Okay, so the term, if there is nothing, again it means there is 1 in front. If there is nothing there, it means there is 1 in front. So 1 times 1 is 1, and then base remains same and the exponents add up. So I can add the base remains same. So this is the rule. So again, let's look at another example. 2x square times 3x square. So now in this case, we will apply 2 times 3 is what? 2 times 3 is 6, and x, this exponents will add up. 2 plus 2, which will give me 6x raised to the power 4. So this looks pretty straightforward. Now we're going to take some more complicated problems when they are not like terms. When the terms are not alike. So there are two options. One option can be when terms are not alike. One can be you have x square and x cube. Okay, if I talk about these two terms, they are not alike because the exponents are not same. Another option can, another condition can be, there can be a term of x square and y square also. So again, although the exponents are same, but the bases are not the same. Another option can be, you can have x square and y cube also. Neither the exponents are same nor the bases are same. So how to multiply these kind of terms? Let's look into the detail. Let's look into the very first option. So if you have x square and x cube, so when in this case the base is same but the exponents are not the same, so we will apply the same rule what we've learned previously. These rules, we can apply the same rules to these unlike terms because the base is same. So when the base is same, I can, if this is x raised to power 2 and I'm multiplying with x raised to power 3, so exponents will add up, base remains the same. So x raised to the power 2 plus 3 is 5, and then the constants will multiply with each other. There's nothing in front, it means there is 1 here. 1 times 1 is 1, and we generally don't represent the 1, so we will remove the 1 and we'll write it as x raised to the power 5 as my answer. Another example I can take, 2x raised to the power 3 times x. So now, or 4x, I'm gonna write it. So 2 times 4 is 8, and x raised to the power 3, bases are same again, but the exponent here it is 1, so 3 plus 1 will become x raised to the power 4. So that's how we multiply when the bases are same but the exponents are not the same. Now the second condition which we've talked earlier is when the terms are not alike, in which the bases are not the same and the exponents are not the same also. So x raised to the power 2 multiply by y raised to the power 2. How to solve this? So I can't do anything with this, I'll just mirror it as it is because bases are not same, so I can't do anything with the multiplication. X square plus y, x times y square, but I can still multiply the constants in front. So what is this? There's a constant here and then there's a constant here, 1. This 1 will still be multiplied with the 1, so this will be 1 x square y square. So let's look into a little trickier problem. X square 2x square times 3y square. How to multiply these two terms? Again, these are not like terms, neither the bases are same, but when you are multiplying unlike terms, you can still multiply the constants and leave the bases and exponents as it is. So 3 times 2, if I multiply these two, 3 times 2 will be 6, and the rest I'll leave it as it is because they are not the like. So x square y square. Yeah. So another question I'm gonna take, let's take another example. 3x square times 9y square. So I can multiply the constants. 3 times 9 is 27, and then x square y square. Again, 3x square times 4x raised to the power 3. Now unlike terms, but bases are still the same, so I can apply the rule where exponents will add up. So 3 times 4, constants can always be multiplied when you're multiplying two algebraic terms. 4 times 3 is 12, and then x raised to the power, this will be x raised to the power 2 plus 3, which will be 12 x raised to the power 5. That will be your answer. And if we wanted to apply the rules which we've learned in the very first slide, the multiplication rule, I'm going to introduce these rules into the picture now. So if it is negative 3x square times 4x cube, what I'm going to do? So again, a negative times this, if there is no sign in front, it is a positive term. Negative times a positive term will give me answer as negative. So answer will be 3 times 4 is negative 12 x, this is square and this is y cube. So exponents will add up. 2 plus 3 is 5. That will be my answer. You can write it as negative rather than writing the negative. Now I'm going to write 3x squared times negative 4x cube will be my answer. So I'd like you guys to pause the video and find the answer for this. So the answer will be again negative 12 x raised to the power 5. Again, a positive terms times a negative term, answer will be negative. Now when you have two negative terms, negative 3x squared times negative 4x cube, what will be your answer? The answer, negative times negative, a negative times a negative, the answer will be a positive. So this will be positive x raised to the power 5. So that's how you solve the problems on multiplication. So let's talk about division also. So now if you are given two terms, one is x, and again we've already talked about the like and dislike terms. So you're given two terms, one is x, another is x square. Again, they are unlike terms, but they have the same base. So let's say, and what I wanted to do is I wanted to divide x square with x. So I'm gonna do it first of all the easiest method, which you guys might have seen earlier also. I can write x square as x times x, means x, this x square always means there are two x's in this one, and then there is a x in the denominator. So if I write 5 times 5 and divide it by 5, so I can divide one of these 5s and my answer will come out to be 5. So same rule I can apply to this, my answer will come out to be x. One of the things which I haven't discussed earlier, when you're writing x raised to the power 5 or x raised to the power 3, just going back to these concepts because I forgot to discuss this. This means there are 5 x's in this. If I write in the extended version, x times x times x times x times x times x, and in this one there are 3 x's, x times x times x. Okay, let's go back to our division rule. So now this was x squared divided by x. My answer came out to be x. Okay, because as I extended them, x times x and divided by x, I got the result as x. I can apply another method. Now these two terms are in division. This symbol, the symbol which I'm representing with the green color now, means that this is a symbol for the division also. You can write it as x squared divided by x, and in the stackable form it will become x squared divide, this is a division symbol, divided by x. Now what I wanted to do is I wanted to learn some rules also, because all the time I won't be able to expand this, because let's say if I've given a term of x raised to the power 10 and divided by x raised to the power 3, I don't want to get into the expansion. I wanted to see some shortcuts. So when the bases are same, in this one bases are same but the exponents are not the same, so what can I do? I can subtract, because they are in division, these two terms are in division, I can subtract the exponents. 10 minus 3, so the answer will be x raised to the power 7. So how you're going to subtract the exponents? You will take the exponent on the top term. The exponent on the top term is 10. Exponent of the top term minus the exponent of the bottom term. That's what I've done here. Okay, and then this all remains in the numerator. So again, let's take another example in this one. X raised to the power 5 divided by x raised to the power 3. So what is the exponent of the top term? Exponent of the top term is 5 and the exponent of the denominator is 3, and x5 minus 3 will give me x raised to the power 2. And if I get into the detailed version, for those students who haven't been able to understand why this is like this, so I can write x times x times x times x times x, 5 x's, and here I have 3 x's, so I can cancel one x with this, another x with this, another x with this. I'm left with 2 x's, x times x, which gives me x squared. So that is the detailed version. Now if you given a term like x raised to the power 3 on top and x raised to the power 5 on the denominator. You will apply the same rule. Exponent of the numerator is 3, so 3 minus 5. What is 3 minus 5? It will be x raised to power negative 2, because the sign with the bigger term is negative. 5 is bigger than 3, so answer will be x raised to power negative 2. So I am not simplifying it furthermore than this point, because we will learn the exponent rules, then we will talk about detail when there is a negative exponent, how to solve this. But for the timing, just remember up to this point. So now another question, when we have x raised to power 3 and divided by y raised to the power 3. Now the bases are same, but the exponents are same. Bases are different, exponents are the same. But I can't do anything about this, so I'll leave it as it is, x raised to the power 3 divided by y raised to the power 3. This cannot be further solved. Okay, and then if you have 3, or let's keep it easy, 6x raised to the power 3 and y raised to the power 3. Again, the bases are not the same, but the exponents are same, so same rule will apply. Whatever I applied into this question, can't do anything. But okay, here it is 2 also, 2y cube. But what I can do is I can divide the constants. So 6 divided by 2 is 3, x raised to the power 3, y raised to the power 3. Here I also divided, there's nothing, it means there is 1 here. Here I also divided this 1 divided by 1, but because 1 divided by 1 is 1, so we didn't end up writing it. So the constants also get divided with each other. Whenever you see the constant, if they are multiplication, constants get multiplied with each other. If their constants are in division, you will always divide them. Let's take a final example. If it is not 7, 8x3 divided by 4x square. Okay, what can I do? Again, constants, we can easily divide them. So 8 divided by 4 will be 2, and then x raised to the power, the exponent is 3 minus 2, so this value will be 2x raised to the power 1, which is equal to 2x. So hopefully you were able to understand the division and multiplication rules. I'll see you with another video. Bye now.